Hello beautiful guys, welcome back to my YouTube channel Gardenland. So today topic is the art and science of grafting. So grafting is a horticulture technique that has been practiced for centuries, enabling gardener and agriculturists to create new plants with desirable characteristics. The age-old method involved joining the tissues of two different plants known as the scion and the rootstock to produce a single healthier and more productive organism. Grafting is a fundamental aspect of plant propagation, playing a vital role in agriculture, horticulture, and even in the world of ornamental plants. In this video, we will delve into the history, benefit, and techniques of the grafting. Historical overview. Grafting is not a modern innovation. Its roots trace back to ancient civilizations. Some of the earliest records of grafting date back to the Chinese and Babylonian culture over 2000 years ago. The Chinese, in particular, were pioneers in the art of grafting primarily for fruit trees. This technique eventually spread to other parts of the world, including Europe, the Middle East, and North America, where it was embraced and refined. Anatomy of graft. Before delving into techniques and procedure, it is essential to understand the key component of graft. Scion. Scion is the upper part of the graft which contains desired characteristics such as specific fruit variety or flower color. It is typically a young shoot or bud. Rootstock. Rootstock is the lower portion of the graft responsible for providing the root system and anchoring the plant. Rootstock are often chosen for their disease-resistant vigor and adaptability to specific soil conditions. Union, the point where the scion and the rootstock are joined together, is known as union. This is critical connection where healing growth occur. Grafting technique. There are several grafting techniques, each suited for different plant purpose and skill levels. Some of the most common grafting methods include wipe and tongue grafting. This method involves making matching cuts in both of scion and rootstock. Grafting a tongue and groove connection for secure fit. Cleft grafting, so suitable for trees with larger branches. Cleft grafting involves splitting the rootstock and inserting a scion into a cleft, ensuring proper alignment. Bud grafting. Bud grafting is used for grafting fruit trees in the summer when the bark can be easily lifted. A single bud is inserted in a T-shaped cut onto stalk. Side veneer grafting. This technique is often used for grafting fruit trees and involves making vertical slit in the rootstock's bark and inserting a scion into the slit. Bark grafting. Ideal for grafting onto branches. Bark grafting entails removing a strip of bark from the rootstock and placing a scion beneath the exposed area. Approach grafting. This technique is used when the grafting to establish plant by joining them at the point where their branches or stem meet. Tissue graft, culture grafting. In modern horticulture, tissue culture techniques are employed to propagate plant under a sterile condition, ensuring genetic purity and rapid growth. Benefit of grafting: disease resistance. Using a disease-resistant rootstock can protect the scion from the soil-borne disease and pests, including plant longevity. Improve yield and quality. Graft plants often exhibit enhanced fruit production, size, and quality compared to their ungrafted counterpart. Precise reproduction. Grafting allows for replication of specific plant characteristics, ensuring consistency in fruit or flower traits. Environmental adaptation. Rootstock selection can help plants adapt to various soil types, climates, and environmental conditions. Dwarfing effect. Certain rootstock can dwarf the scion, making it suitable for smaller spaces or easier harvesting. Application of grafting. Fruit production. The grafting of fruit trees is common practice in orchard, enabling the cultivation of a wide range of fruit varieties on single tree. Wine and vineyard industry. Grafting is a vital in propagation of grapevines, allowing vineyards to select a rootstock that resists pests and disease. Ornamental plants. Many ornamental plants, including roses and flowering shrubs, are propagated through grafting to maintain desired trait. Forestry. Grafting can be used to accelerate the growth of desirable tree species for timber production. Research and conservation. Grafting play a vital role in preserving rare and endangered plant species by cloning them. Challenge and consideration. Compatibility. Not all the scion and rootstock are compatible, and selecting the right pairing is essential for grafting success. Disease management. Grafted plants require a delicate disease management as a pathogen can exploit the union between the scion and rootstock. Skill and technique. Grafting requires skill and practice. An inexperienced grafter may encounter difficulties. Timing. Timing is critical for successful grafting, as our different plants and technique require specific seasonal conditions. Conclusion. Grafting is an ancient horticulture art that has evolved and thrived throughout the centuries. Its profound impact on agriculture, horticulture, and environmental plant cultivation is undeniable. As we continue to explore the vast world of plant propagation, grafting remain a valuable tool for producing healthier, more resilient, and higher yielding plant, whether in the orchard, vineyard, garden, or laboratory. The art and science of grafting continue to shape the way we cultivate and appreciate the world of plants. So this was all today video. Thank you guys for watching the video. Bye. I love you.